Lab 14, physical and chemical properties of materials. Today we are going to test materials, and we're going to test their physical and chemical properties. Remember, a physical property is one that we can identify without seeing the material, reacts with another, so usually you're going to use one of your five senses. A chemical reaction is when you see a reaction from one reacts with another substance. Okay, so that's what we're going to do in lab number 14. We are going to be testing for color, light transmission, luster, texture, flexibility, hardness versus glass, electrical conductivity, density relative to water, and reactive with hydrochloric acid. Our materials, going down through the list, we're going to have aluminum, carbon, copper, glass rod, granite, iron, limestone, formica, polystyrene plastic, ceramic tile, piece of wood are the items that we are going to test. The first test that we're going to look for is color. So just take a look at the materials, okay, and describe the color of each of the items. These are in order. So first, color of the aluminum, color of the carbon rod, color of the copper, glass rod, granite, iron, limestone, formica, polystyrene plastic, ceramic tile, and wood. So please write down their color in the first column of your data table. Okay, next is we're going to look at light transmission. Light transmission is you're going to hold the material over some printed material, and you're going to observe whether you can see the print clearly, which is transparent. If you can see the print but it's blurry, which is translucent. And if you cannot see it at all, it is considered to be opaque. So we'll just take our piece of aluminum, we'll put it over the material. Okay, very good. Next, we're going to take our carbon. Next is our copper. We're going to use a glass rod, but I'm going to actually use this glass slide to help you with that, because the rod does kind of make it blurry, and we know that glass is not blurry. Okay, next we have our piece of granite. Next we have our piece of iron. The limestone, formica, the piece of polystyrene plastic, the ceramic tile, and the piece of wood. And again, that is light transmission. Next, we are going to look at luster. Okay, luster is you're going to hold the material near a good light source. Observe how well it reflects off your material. Record whether it is very shiny, somewhat shiny, or not shiny at all. If it is very shiny, it is considered to be brilliant. If it is somewhat shiny, it is considered to be glassy. And if it is not shiny, it is considered to be dull. Okay, so we'll just take a look at these items again. Okay, so looking at your piece of aluminum, is it, out of those three, you're looking at brilliant, glassy, and dull. Make your observations for the aluminum, the carbon, the copper, the glass, the granite, the iron, the limestone, formica, polystyrene plastic, ceramic tile, and your piece of wood. Okay, so you need to look at that luster. Okay, texture. Okay, this might be hard to see on the video, so I'll kind of go through. So your aluminum is going to be smooth. Your carbon is going to be smooth. Copper is smooth. Glass rod is smooth. Your granite is kind of gritty and rough. The iron is smooth. Your limestone is kind of rough. Okay, gritty. Formica is smooth. Plastic is smooth. Ceramic tile is smooth, and your wood is kind of grainy feeling. Okay, so that is your flexibility or your texture. Next, we're going to look at your flexibility. So I'm going to flex each one of these materials. It is going to, if it doesn't bend, it's going to be not flexible. If it bends somewhat or slightly, it's going to be somewhat flexible. And if it bends really easy, it is considered to be very flexible. Okay, so we'll take a look here at your aluminum. Okay. So what do you think there? Okay, my carbon. You'll notice that it doesn't bend at all. This is your piece of copper. The glass rod. The granite. The iron. Okay, that's about the same pressure that I put on the copper and the aluminum. The piece of limestone. Okay, the formica. And I'll kind of show this here at an angle so you can kind of see that it has a slight bend to it. The piece of plastic. The ceramic tile. And the piece of wood. Okay, next, we are going to test whether it's harder than glass. So I am going to take my piece of aluminum here. I'm going to scratch it. We'll wipe it off, and as you can see, there is no scratch, so it is considered to be softer. Okay. Carbon, and again, you got to find a spot that. Okay, so I scratched it. There's nothing there. Okay, so if it doesn't scratch, it has to be softer. If it does scratch, it is harder. Your piece of copper. Okay, again, looking down here, there is nothing there. Glass. Okay, so if you think about glass, can it really be harder or softer than glass? Glass is glass, so please make an educated guess on that it's glass is glass, so can it really be harder or softer? Next, the piece of, okay, granite there. So you can kind of see right there that we do have a scratch. Okay, I'm gonna have to find a new spot now. Okay, I'm gonna take a look at the iron. Okay, the piece of iron, okay, it does leave a little scratch on it, so it is harder. Next, as we have the piece of limestone. Okay, I scratch it, there's nothing there, so the limestone is softer. And these are hard to see, so I'm kind of giving you the answer. The formica, definitely softer. The polystyrene plastic, nothing, so definitely softer. The ceramic tile. Okay, I'm trying to get it good. Okay. So that is harder. And then your piece of wood, nothing, so it is softer. Okay. Next, electrical conductivity. Does it conduct electricity or not? So we're going to use our wiring harness with our light bulb on it, connect it to a battery. Okay, with our alligator clips, we're looking to see if the light bulb turns on. So here is the piece of aluminum. Try to get that up there. So the carbon, copper, piece of glass, granite, iron, limestone, formica, plastic, ceramic tile, and the piece of wood. Okay, so please write down whether it conducts electricity or not. Okay, the last thing that we're going to do is we're going to take hydrochloric acid and we're going to see whether it is, density relative to water. Okay, so we're going to take each of our items. Okay, we are going to place it in the water, but we are to push it down and see if it comes back up. So this is the aluminum. As we can see there, what happens to the aluminum. Okay, next we have the carbon rod. Okay. Next, we have the piece of copper. Should be able to record this. If it is less dense, it floats. More dense, it sinks. So far. Next is the piece of iron. Limestone. Formica. Again, it says to push it down to the bottom if it comes back up. Okay, so we can see there about Formica, more or less dense than water. The piece of plastic. Okay, I need to push it down. Okay, so that is also more dense. The ceramic tile. And the piece of wood. Again, I got to push that down. As you can see, I'm trying to push it down. I'll use my finger since it's just water. And you'll notice that it comes back up. Okay. So those are your items with relative density to water. Okay, next, reactivity with the hydrochloric acid. Okay. What I would normally do is I would take 2 or 3 drops, place it on each of the items, and tell you whether it reacts with hydrochloric acid or not. I'm just going to tell you, because it is kind of hard to see, that your aluminum does react. Okay. Carbon also reacts with hydrochloric acid. Glass does not react. Granite does not react. Iron does react, as well as a limestone, it does react. Formica does not react. The polystyrene plastic does not react. Tile reacts, and wood does not react. And copper, I forgot it, it does also react with hydrochloric acid. Okay, so that is your data. Next, you need to answer questions numbers 1, 2, and 3. Please make sure that when you do this, that you are grouping them, okay, so that you can help identify those materials, okay, and also you need to answer question number 4 as well. Thank you.